Hey everybody, welcome back for our 10th video on this AP review series. And last time we looked at the fundamental theorem of calculus, and we looked at some definite integration and indefinite integration. And after thinking about it a little bit, I decided to put together a couple of videos on different strategies for integration. I'm not going to go over every shortcut that you should know for antiderivatives. Most of them are working backwards from your derivative rules, and I'm pretty sure if you're watching those you probably have down pretty well. So that should be an easy thing for you to review on your own. And I want to focus instead on different strategies for integration. So we're going to start off with the most basic antiderivative rule. How do you handle powers of x? And I think this is something we all know. We add 1 to the power, so it becomes x to the 4th, and then we divide by that new power to undo the derivative power rule, and then plus c. Remember, you can always retake the derivative of your antiderivative to check it. So some different variations on this that I think are important to mention today. How do you handle radicals? The same way that you handle radicals with derivatives. You're going to rewrite this as x to the 1/2, and then apply the power rule. So we're going to add 1 to the exponent, x to the 3/2. And then instead of dividing by 3/2, I'm going to simply multiply by 2/3. And then I'm going to get it back into the form that it was given in. So it's going to become the square root of x cubed plus c. Okay, what about powers in the bottom? The same way we did with derivatives. We will rewrite using a negative exponent, and we'll apply the power rule. So we're going to add 1 to the power. That becomes x to the -1. And then we'll divide by that new power the same way, -1. And then simplify. So I'm going to kick the negative to the front and then make this 1/x plus c. So really basic rule, and then some different variations that I think are important. I think most of you guys are probably going to be pretty quick at this, and this is just a quick reminder to make sure you know what to do. All right, so now some slightly more difficult ideas. Let's call this simplify then anti-derive. Simplify, then anti-derive. We're going to look at 2 problems. For your first problem, let's say you have to anti-derive something that looks like this. In order to do this problem, we can simply FOIL it out and then anti-derive the terms from there. So that's the simplify step. So when I expand this out, we're going to have x to the 6th plus 2x cubed plus 1. And then we can anti-derive will be x to the 7th over 7, add 1 4, so 1/2 x to the 4th plus x, and then plus c. So that's one variation of simplify then anti-derive. Another one is the classic divide and conquer, right? Maybe you have one term divided in the bottom. It's really key that it's one term, otherwise this doesn't work. We can divide both terms in the top, x, to simplify this fraction. X squared divided by x would be x. 1 divided by x would just be 1/x. And then now we can anti-derive. This would give us x squared over 2. And then this is the natural log of the absolute value of x plus c. All right, so again, more basic rules, but good reminders and things you just want to know really, really well going into test day. All right, let's look at some other possibilities. The next topic I'm going to call undo the chain rule. And this could be considered U substitution, which we'll get to in a minute. But I separate this one because I think you need to do this without U substitution. Here's what I mean. Maybe you have a problem like e raised to the power of 2x. We all know the antiderivative of e to the x is simply e to the x. And any variation of it will also stay the same. But if we were to anti-derive this and just say e to the 2x, if I took the derivative of this, I'd have to multiply by 2, which would not be what I had before. So we're going to undo the chain rule by multiplying times 1/2 to get rid of that times by 2 that would come plus c. Okay, for our second example of this undo the chain rule, let's try a trig function. Let's say the sine of pi x. All right, so antiderivative of sine is negative cosine, and the inside is going to stay the same. And then we will multiply by what's going to undo this chain. If I retook the derivative, I'd multiply by pi. So I'm going to multiply by 1 over pi. So I'll rewrite this as negative 1 over pi times the cosine of pi x plus c. And again, you could do this with u substitution, but I prefer you not to because of the time that that would take. And these show up enough that you want to be able to get through it. Okay, and on to that point, why don't we go ahead and look at u substitution in this topic. U substitution is a relatively simple concept. Once you get it down, you do enough practice with it, you should feel pretty solid. But let's put up a problem to look at. What if we have an integral like this? X over x squared plus 4. Now, looking at this, you can't divide and conquer because it has to be flipped over. You have the x in the bottom instead of in the top. So we have to come up with another way. And the thing that I always talk about with u sub is looking for the derivative connection. So if you pick some part of this expression, usually that part is inside of something else. In this case, inside of a fraction is inside of something else. And if you take its derivative, you see that in the problem. I call that the derivative connection. So your first job is to define what that u is. And in this case, I'm going to pick x squared plus 4, the denominator, because I know the derivative of x squared is 2x, which is a multiple of the numerator x. That's the derivative connection I'm looking for. So I take the derivative, would be 2x and then dx that we've multiplied over. And then I divide by 2, so 1/2 du is equal to x times dx. Now the rewrite step. We're going to replace x dx with 1/2 du. So when I do that, I'm going to slide the 1/2 to the front. And I could put the du in the top, or just simply write it as 1 over and then write the du here. It normally goes. And then x squared plus 4 in the bottom is replaced by u. And then this becomes a very easy antiderivative to take. 1/2 natural log absolute value of u, c, and then 1/2 ln. And I'll get rid of my absolute values because x squared plus 4 is positive. And then that is the solution left. Really, really easy. Look for that derivative connection. That's your clue that u sub is the way to go. I want to do one more problem with this, just to do one that's got definite integration as part of it. So for our final problem in this little lesson, let's look at the integral from 0 to 2 of x squared times the cosine of x cubed. Okay, clear cut u sub because of the x cubed inside of cosine and then the x squared on the outside. So let's begin. Pick the u, in this case x cubed. Take the derivative of it, 3x squared dx. 1/3 du is x squared dx. And then right here, when you have to do a definite integral, it's decision time. You have two choices. Either you continue the problem and you evaluate it as an indefinite integral, like we did in the previous problem, put u back in and then evaluate from 0 to 2, or you modify the limits of integration by substituting them into u right here and getting a u value so that you can rewrite everything in terms of 2. So u of 0 would be 0, and then u of 2 would be 8. Okay, so now our rewrite step. 1/3 goes to the front. Integral goes from 0 to 8. And then we're going to have the cosine of u du. And then now we're ready to antiderive and evaluate. So the antiderivative will be 1/3 sine u. And the beauty of doing it this way is I don't ever have to put that u, x cubed, back into the problem. It's already taken care of. So 1/3 times the sine of 8 minus 1/3 times the sine of 0 is equal to 1/3 sine of 8. That's it. Either way, you're going to get the same answer. It's just personal preference. I do like this for problems where you have to rewrite an integral instead of evaluate it. So just rewriting it in terms of u, this is useful to know this method. comfortable with both. They're both useful in various situations. So just keep practicing, review both of them, and you should be all set. All right, next time we're going to look at some more advanced integration strategies, and good luck with the rest of your study.